Hello and welcome to a video on parallel and skew lines. So the lines that you're looking at right here, you can see this is a drawing of a three-dimensional cube, and there's two lines, the red line and the blue line, line 1 and line 2, and you can see that these lines will never touch, but they're definitely not parallel. So if we have the idea that parallel lines are lines that never touch, we have to kind of improve on that definition, because those lines are not parallel, they're skew, and yet they'll never touch. So the way we're going to do that is we're going to first of all kind of keep this visual in our mind when we think about what skew lines are. And when we talk about parallel lines, the first thing that we're going to say about parallel lines is that they have to be coplanar. They have to be in the same plane. So these are coplanar lines that do not intersect. Okay? Now, the way that we usually indicate these on the lines themselves are with these little arrows. So these arrows are used on the lines to indicate that they're parallel. So as a rule, we don't want to really look at something. We're going to kind of bend this rule a little bit. We don't really want to look at something like this and say that it's that the lines like TP and UQ are parallel without actually marking them parallel like that. But we're going to bend that rule, and we're just going to assume that things that look parallel are for now. Okay, so but in general, that is what we like to see. The symbolic notation for parallel. So if I wanted to actually just say this without using all the words, to say line AB is parallel to line CD, and nobody wants to write all that out, we just write the symbol for line AB, and we use, it looks kind of like a slanted 11, but I like to make it a little bit taller, so I went through the writing a little bit so I could kind of emphasize that. Line AB is parallel to line CD. Okay, parallel planes are just planes that do not intersect. We don't have to say coplanar in this case. Planes that do not intersect. Often we think of something like the floor and the ceiling. This is an S right here. Okay, and the symbolic notation for that was we use the same two lines there. So we just say something like plane J is parallel to plane K. Okay. And now we've got skew lines. Now the lines that I drew on here are definitely not skew, the ones that I was highlighting. Skew lines would be lines that never intersect, but they're not parallel. Like, for example, that line and that line. That would be an example of skew lines. I'm going to just show you in different colors. It's the same way that you saw in that other example. This would be an example of skew lines, because this WV line is in the back. So these are they're not coplanar, and there's no way that you can draw the red line and the blue line in a single plane. So these are actually non-coplanar lines that do not intersect. That do not intersect. And some examples of pairs of coplanar lines would be like the two that I drew, so WV and TP. Those are skew lines, non-coplanar lines. So WV and TP. Another example, I'll say another one that's skew to TP would be SR, for example. Right? SR and TP are skew lines. And then another example would be something like maybe this line here, and how about this one over here. Those two lines are also skew. Kind of covered it up, can't see what it is, it's TW. Alright, so TW is skew with QU. So let's just TW, line TW is skew with line QU. Okay, so that's the idea. Now let's look at some examples. So here's a figure, and we're just going to name all segments parallel to AE. So look at AE. First find AE, and I'm going to kind of highlight it here. Here's AE. And I want every segment that's parallel to that segment. And actually, since it says segment AE, I think I'm actually just going to highlight just the segment instead of the line. All right, let's pause it and see how you guys can do with that. Okay, so I highlighted the 3 segments that are parallel to AE, and I also wrote them in here using segment notation. All right, now 2 examples of parallel planes. Parallel planes, now there's actually 3 examples in the diagram. There's the top and the bottom. So this plane on the top and this plane on the bottom. There's the left and the right, and then there's the front and the back. Well, the easiest ones for me to kind of highlight and show you would be the one on the left and the one on the right. So there's 1. So let's write that one. So we can just choose any 3 non-collinear points. So plane, I'll just choose, you can also choose all 4. So plane EADH. Whoa. That is not coming out right. So let me just erase that. Plane EADH is parallel to plane FBCG. FBCG. And it doesn't really matter what order you say the letters in, and honestly you only need 2. So you only need 3 of the letters. You don't need all 4 of the points. All right, the other ones, I'm going to just say the top and the bottom. So why don't we show those in blue and see if we can kind of get a feel for this. So there's the bottom and there's the top. So that would be plane ADCB, ADBC, like I said, it doesn't matter what order you say them in, and plane EHGF. All right, what about naming the segments that are skew to GH? So I'm going to erase all this other stuff and see if we can kind of see what's skew to GH. So let me first find GH. GH is in the back here. So I basically am looking for any segment that's neither parallel nor intersects. So I don't want this one because that intersects. I don't want CG. I don't want EF because it's parallel, or AB because it's parallel. So we need to find some that are skew. So here's one that looks like it will never cross HG, and here's one that looks like it will never cross AG. Are there any others that will never cross it, but are also not parallel to it? Well, here's one here that will never cross it, but it's not parallel to HG, and then here's one here. And again, are there any others? And all of the other segments that are not highlighted are either touching it, so they're not skewed to it if they're touching it, or they're parallel. So we're just going to write those in. Okay, so there they all are. Now let's try to do the same thing with a slightly more complicated diagram. So let's name all the segments that are parallel, or at least that appear to be parallel to JK. So let's highlight JK first. Here's JK. And there's not that many. As many segments as you see in this diagram, there's only one that's actually parallel to JK. This one right here, OP. Okay, so OP is the only one. All segments parallel to NS. So let's find NS. NS is this one. Now that's a different story. This one is parallel to this one, and this one, and this one, and this one. So let's write all those in there. All right, now let's name a plane parallel to JKL. Plane JKL. So there's JKL. So we're talking about this whole front polygon. It's a pentagon. It's 5 sides, and this is the only one that's parallel to it in the back. Front and back are parallel to each other. So we can say plane, and we can pretty much choose any 3 letters, so SRQ will work. You can also say all 5 letters and you won't be wrong. Just we usually pick the shortest ones. All right, let's name 4 segments skew to segment P, the segment RQ. So let me erase what I have here. Let's find segment RQ. So RQ, where's the R and there's the Q. Okay, so here's segment RQ. Now we want to find 4 segments that are skewed to it. I'll pause it and then I'll highlight them and show you which ones they are. Okay, so I think the easiest way to find these is actually to find anything that's touching either Q or R will not be skewed to it. It'll be intersecting. So we're going to rule out everything that's touching those 2 points. And then anything that's parallel. So there's only one segment that's parallel, and that's ML right here. Everything else, you just can find the ones that are never going to touch it. So for example, and we'll just do these in a different color. How about blue? This one will never touch. This one down here will never touch, and neither will this one. Are there any others? Well, over here, this one, ML, is parallel, but this one will never touch. Actually, let's do that in a different color because it's a little bit harder to see. So how about this one? This one will never touch. And we only need one more, but let's just find all of them. This one will never touch. This one will never touch and is not parallel, and same thing with this one. So all of these, 1, 2, 3, 4 down here, will never touch. And then these blue ones that go, the longer ones, will also never touch. So let's just pick 4 of those and write them down. And I just went ahead and wrote all 7 of them down. Okay, so those are all that are skewed. Did I miss any? I might have missed a couple. So there's actually, may as well be thorough. There's also this one and this one. Those are also skew to RQ. So I'm just going to write those down too. You know what? I started to write them down, and then I realized that they're not skew because these 2 lines will eventually cross. So the lines are intersecting. They just don't intersect in the diagram, but they will eventually intersect. So we don't really want to call those 2 skew. Okay, let's just do a quick review now. We've talked about transversals and the different kind of lines, but since the focus was on parallel lines, let's just make this clear that these are also transversals even when the lines are not parallel. So I'm just going to write in some examples of each one. So remember there's 4 pairs of corresponding angles, so these are pairs of angles. So I'm going to write down a pair of corresponding, like 1 and 5. That's a pair of corresponding angles. Hopefully this looks familiar from yesterday. The top left are corresponding. The top right, so 2 and 6, are also corresponding, right? They're in the same position, the top right. So angle 2 and angle 6. I'm going to go back to putting my angle marks there. Okay, and then see if you can find the other 2. Okay, so there's all 4 pairs of corresponding. What about the 2 pairs of alternate interior? So alternate interior, remember, on the inside, but alternating on different sides of the transversal. So angle 3 and angle 5. Now we're not saying anything's congruent now because the lines aren't parallel, so we have to be careful of that. And the other ones are angle 4 and angle 6. All right, alternate exterior would be the ones on the outside of the 2 lines that are being crossed, and different sides of the transversal. So angle 1 and angle 7, angle 2 and angle 8. And consecutive interior is another way of saying same side interior. This is just used by different textbooks and different writers and different teachers, but they mean the same thing. So same side interior and consecutive would be these 2 and these 2. Okay, so why don't you guys try an example and see if you can look at the angle pair for A through F and see if you can figure out which type. Now we don't have the one that's missing here that we talked about before is looks like same side exterior is not even an option. So if you do see it, you can still name it. We have a name for it. We can still name same side exterior. But if they're not any of these or same side exterior, then we just say none. You can just say none. There's really still a relationship, but we don't have a name for it. Okay, try them out. Okay, there you go. Now let's try a challenge. And now when you do these, what you want to do is you want to kind of block out what you're not looking at. So you want to just focus on one piece at a time and see if you can name them doing that. Just whatever piece has the 2 angles that you're looking at, and I'll give you the key in just a second. Okay, and there they are. Hope you found this video helpful.